Hi everyone. After our work with Lewis diagrams for molecules and structural diagrams for molecules, it's time to introduce the idea of multiple bonds. This is an extension from our earlier work, and this table might look familiar. The number of bonds always is going to correspond with the number of bonding electrons in the individual atomic Lewis diagram. Hydrogen, fluorine, chlorine, bromine, and iodine all have one bonding electron. They're always going to form one bond. Or to say that in a different way, anytime we're drawing a picture with hydrogen, fluorine, chlorine, bromine, or iodine in it, there must be one dash that touches each of those atoms. It would look like this. The bond always has to go somewhere. The bond must be bonded to something. We can't have a bond that goes nowhere. However, it would always look like that. With two bonding electrons are oxygen and sulfur. Two bonding electrons, two bonds. That could be two single bonds going in two different directions. They don't have to go left and right. One could go up and one could go left, but two single bonds. But now this is the first time for us to see a double bond. Two bonds going in the same direction. They could both be going up or left or right or down. Here I have them going to the right. One double bond. Again, there would be some other atom over here. Can't be a bond to nowhere. With three bonding electrons and forming three bonds are boron, nitrogen, and phosphorus. Now, depending on the situation, we might have three single bonds, a single bond and a double bond, or even a triple bond. All of those are three bonds. Anytime we're drawing boron, nitrogen, or phosphorus, there must be three bonds touching it. With four bonding electrons and forming four bonds are carbon and silicon. Here, there's four different possibilities, and it's going to depend on the molecule itself. Will we get four single bonds, a double and two singles, that's four, two double bonds, or even a triple and a single bond? It's important to highlight at this point that there is no such thing as a quadruple bond. That does not exist. When we're working through a question, as long as this table is satisfied, if the correct atoms are there and this table is satisfied, that's how we know that we're correct. As long as boron always has three bonds, we're good. It's never going to have two, never going to have four. Boron, nitrogen, or phosphorus must have three. Carbon has to have four. There's different possibilities into how those bonds are going to be arranged, but the table must be satisfied. Here's a couple of examples. Three examples, as a matter of fact. Here, my first one I finished off already. Here's O2. It's two oxygen atoms bonded to each other. My first instinct, might they just have the single bond there? Oh, there's two oxygens bonded together. That, however, would not satisfy the octet rule, so it's not correct. Plus, this table wouldn't be satisfied. Oxygen must have two bonds. So I might take a second to realize, oh, I need the double bond there. When I see that, each oxygen now has two bonds touching it. It's O2. Do we have two oxygens? Yes, there's clearly two O's there, and each of them has two bonds. It's correct. Here's another example, H2CO. I have two hydrogens, one carbon and one oxygen. Hydrogen is always going to have one bond, carbon's always going to have four bonds, and oxygen's always going to have two. I might have to wrestle with it. You might have to use your eraser. You might make a mistake. But no matter what you do, you'll struggle, you'll think, you'll try something, and eventually you'll arrive. So here, in the end, I'm skipping to the end, it looks like this. Two H's, a C, and an O. You might try something first and have to erase it. You might try something again, but once you have something, just check to see, do you have the correct number of atoms? Are there two H's, one C, one O, two H's, one C, one O? Is that table over there satisfied? The table says hydrogen is going to have one bond. This hydrogen has one dash touching it. This hydrogen has one dash touching it. The hydrogens are good. The carbon down here, the table says, must have four bonds. Look at this carbon. It has 4 dashes that are touching it. It has 4 bonds. And the oxygen has 2 bonds, and that satisfies the table. If there's the correct atoms and the table is satisfied, you're correct. It might look strange, it might feel uncomfortable, but that's all that it takes. It's worth also highlighting that these are structural diagrams. I'm not showing lone pairs. If we were asked for Lewis diagrams, we would have to include the lone pairs on the oxygens over here. One more time, HCN. We will notice that sometimes carbon's going to be first. When we have a formula given to us and we see a bunch of carbons first in the formula, it probably is a signal that they're central somehow and the other stuff is all around the outside. However, if we see carbon not first, believe it or not, this is the formula's way trying to give us a heads up about what the structure might look like. Look at this one, H2CO. H2CO. There's a kind of a symmetry there. Look at this one, it goes HCN. So that's what my first instinct is going to be. I'm just going to put HCN. HCN. I have all of the correct atoms, HCN, but is that correct? Hydrogen's supposed to have 1 bond, which this one does. Oh, this carbon only has 2 bonds. It must have 4 bonds. Nitrogen here only has 1 bond as well. Nitrogen must have 3 bonds. Nitrogen has to have 3 bonds. There's only one way that they can go. So then I might go like this. Then I think, okay, let me double check now. HCN, HCN, I have the correct atoms. The hydrogen is supposed to have 1 bond. Here it is. This 1 dash is touching the hydrogen. Carbon's supposed to have 4. It's a single and a triple. Well, that makes 4 bonds. And here's the nitrogen with a triple bond. Oh, the table is now satisfied and I have the correct atoms. This is a correct structural diagram. When we're asked to draw a diagram, we can work through this idea of fitting puzzle pieces together. However, we must also be conscious that the possibility exists for multiple bonds. There might be a double bond or a triple bond. When push comes to shove in the end, if this table is satisfied and we have the correct atoms, we're going to be correct. Even if it looks strange or something like that, we're going to be okay. So take your time. It's okay if you make a mistake. You might not get to the answer immediately. It's kind of a puzzle. It's a logical puzzle to figure out. We're trying to satisfy the bonding rules of this table. Take your time, do your best, and I hope this helps.